Hello everyone, welcome to this new video. So in this today's new video, we'll be solving the problem find transition point. So this is an easy level question and has been asked by Amazon, and the company tags are yes Amazon, and the topic tags are arrays, searching, data structures and algorithms. All right, and let us see the question. Let us understand that given a sorted array containing only zeros and ones, find the transition point, that is the first index where 1 was observed and before that only 0 was observed. Okay, so I feel like this is this is not a correct framing of the question according to the GFG. Like what they actually expected is not this. They could have mentioned the first occurrence of 1. That is fine, because I'll be showing a test case where this statement is actually, it doesn't make sense. All right, so we'll see that later. So these are some examples, and you can even see the code to your right side. So let us first understand the question. So n equal to 5 array is very first example, n equal to 5, and array is triple zero and 1 1. All right, and so according to the question, you need to return the value of that index where you can find the where you can find the first occurrence of 1, and to the left of it you find a 0. All right, and it's been mentioned very clear that it is a sorted array. All right, all the arrays that are going to be given to you are sorted arrays. Fine. So if you see the first occurrence of 1, that means you can infer that to the right of that, all to the right of that, either if there are any elements, if there are any elements, then all of them would be 1. If there are no elements, then it's fine. All right, so in this case, where is the first occurrence of 1? Here at this particular point. So this I is equal to 3, because this is 0, this is 1, 0, 2, this is 3, this is 4. All right, so I equal to 3. So in this case, I equal to 3 is the answer. And this also makes sense, because at I equal to 2 I find a 0. All right, but in the GFG test case, if you enter 1 1 1 1 1, something like this, all right, there are no zeros, only ones. In this case as well, according to the GFG, answer is I equal to 0. But it doesn't make any sense, because they have clearly instructed that before that only 0 was observed, but we do not find any 0. In this case, the answer should be -1, but still they are they're putting that answer as I equal to 0 in this case. So only the first occurrence of 1 is being considered. There is no consideration of zeros, like either the zeros are there or not. So it's fine according to them. So I just wanted to highlight this point. So some of them might be confused. So do not confuse. In this case, I equal to 0 is the answer. And what is the case if all of them are zeros? So if all of them are zeros, like in the second example, 0 0 0 0 0, so as you do not find any sort of one, all right, any one, so in this case your answer is equal to -1. All right, in this case your answer equal to -1. So in this case, answer equal to I equal to 0, in this case I equal to 3, and in this case answer equal to -1. All right, so these are the answers, various answer possibles. So either you have zeros and ones, in that case the very first occurrence of first occurrence of 1, and if in case all are ones, you can put the 0th index as the answer. In case all are zeros, you can return -1. Great. So this is the particular thing. So with these calculations, you can frame two methods. The first approach would be to iterate. Okay, iterate and count zeros and count ones. All right, count zeros and count ones, and from that you can write these three conditions, like this particular thing and this particular thing and this particular thing. You can do that, and again a second iteration if there are ones, and if there are no zeros, you can return 0, because zeroth index is the answer, and if there are no ones, you can return -1. So you can do like that. That is one approach. And second approach is iterate and find. Iterate and find. At the very first instance of finding 1, you can break the loop and return that particular answer, or you can just return that I, and it's done, it's over. So both of these are O of n, right? And size of the array, time complexity, worst time complexity is O of n. But in the question, it's been clearly mentioned, like you need to do this in log n, right? So that is the reason we'll be using upper bound. We have already seen several videos on my channel regarding upper bound, and this is also very evident because it's been clearly mentioned that the array is sorted, right? The array is sorted. So whenever you find that an array is sorted and you are required to find an element or an element greater than the particular element, you can use upper bound, lower bound, all this stuff. Fine. So what does upper bound do? It's just like a revision. You can see several videos at the initial initial videos of this playlist. So all of them mostly cover the upper bound. So upper bound in the sense this returns either, so it's according to the convention that we are using, either the index or the value of the particular element as well. Value of the element that is greater than the target you are looking for, greater than the target you are looking for. All right. So if let us assume I'm looking out for, all right, so let us assume this is the array given, array of taking 1 2 3 4 5. All right, and if I'm looking out for the index of that particular element that is just greater than 2, then I'll be using upper bound, and let us assume this array name is ARR, and it is of size n. So in that case I'll be writing upper bound array comma array plus n, and what's the target I'm looking? 2. So in this case it returns me the address. All right, address of 3. All right, address of 3, because what is the element that is just greater than 2? 3. So it will return me the address. And when I keep a star to it, put a star to it, this will return me the exact value, that is 3. So when I put a star to it, it's a pointer to the address. So pointer to the address returns the value that is present at that address. So in that case I'll be getting a 3. And if in case I'm writing like this, upper bound of array plus n comma 2 minus array. So array is the sense initial address. All right, in array point like this address, this starting point. Okay, starting address. So when I subtract the address of 3 minus the starting address, I would get this answer as 2, right? Because there are two elements in between. So two distance, there's a distance of 2 from the beginning. So I'll be getting in this case the answer as 2. So what does this indicate? This indicates the index. All right, index of the element that is just greater than 2. All right, so whatever the convention that you're following, according to it you'll get the answer. Now because the array is sorted and you are required to ask an element that is like 1, you're required to find the value of first occurrence of 1. So that only happens like 1 is just greater than 0. So you can just apply the upper bound on array plus n, the size that's been given, and comma 0, and that gives you the value as the index value of the one that is just greater than 0, like the first occurrence of 1. Great. But what if it is like this, like this particular case where all of them are zeros? In that case it will return this final end position address. All right, end position address. So if I just subtract this from the array beginning, then I'll be getting the value as n. All right, so this is the array end and this is the array beginning. So when I subtract these two, I'll be getting n. So that is the case. So if I find that the one position that I'm getting after applying the upper bound as n, that means I did not find any values of any 1 in my array. So in that case I'll be returning -1. In other cases I'll be returning the index itself. Index is basically upper bound minus the array. So array means the initial address. Great. So that is what we have written here. So int one position is equal to upper bound of array comma array plus n comma 0 minus arr. So with this gives the one index. All right, this is the convention for finding the index. And now if one position is greater than n, okay, one pos or one position is greater than or equal to n, that means we have reached the end of the array. So we did not find any ones in our array, so return -1, else return one position. That's it. Fine. I hope you people understood. Let us even run the code for your reference and check. It works fine, there is no doubt. All right, so this is the case I was talking about. Yeah, 1 1 1 1. So if let us assume all of them are ones, and see in this case, according to the question the answer must be -1, but here its answer is 0. So according to the question you must also, before that only 0 was observed, but in case there is no 0, so in this case it must be -1, but still the answer is 0. Fine, anyways, it's up to GFG. All right, so for your reference, codes in Java and Python are also attested in this description. Please check them out. All right, if there are any doubts, please let me know in the comment section. So thank you for watching guys. Stay tuned.